Hello guys, welcome to the Have a Lab and welcome to Objective 10 also. You made it this far. And today we're going to be talking about solving an exponential equation by using natural logarithms. Okay, and we're gonna have to put our answer in logarithm. We're gonna work with logarithms basically. Okay, and what this means, what this questions just mean is we're gonna have to find a particular variable, which in this case we have to find x, right? Because it asks to solve for x, right? Well, and in the process of solving for x, we're gonna have to implement the logarithm functions in the equation. Okay, so we have to put in logarithm functions because in this kind of question, logarithm functions are is what makes it solvable. I'll put it in that way. Okay, so when we apply logarithm functions in this kind of equations, the equation is more solvable and we can work with it more. Okay, so let's start. This is exponential x plus 9 equals 4. Basically, what exponential just means is just power. Like say 5 to the power of 3. It's 5 times 5 times 5. That's an exponent, right? Okay, so whenever we're dealing with exponent, just know we're dealing with powers. Whenever I say exponent, just know we're talking about powers, okay? So this is exponential x plus 9 equals 4, right? So here is when we have to introduce the logarithm functions. Because from here, we can't do anything actually. We can't really do that much unless we introduce the logarithm functions. Okay, so let's put it in. This is ln times exponential x plus 4 plus 9, sorry, equals ln 4. Because remember, whatever we do at the right-hand side of the equation, we have to do at the left side of the equation. Okay, so we did it here, we also did it here. So this is ln e to the power x plus 9 equals ln 4, right? And based on logarithm function, that's to do with exponents. So I'm going to give you an example now. So let's say we have a question like log 3 5 squared. Okay, we're not going to say log 3 because if in normal circumstances, if you're given 5 squared, it's basically saying 5 times 5, right? But in this case, we're not going to do that, right? We're going to have to take in 2 to the front here and multiply 2 by log 3 base 5, right? So we're going to say 2 times log 3 is 5. So we're not going to square 5 like you may think. We're not going to square 5 and say log 3 to 25. We're not going to do that. All we're going to do is we take 2, put it at the front of the logarithm function, and then multiply by whatever we're working with, okay? So that's the same concept we're going to use here. As you can see, the power here is x plus 9. So we have to take x plus 9 and put it at the front and multiply that by ln e in this case. Okay, so that will be x plus 9 times ln e equals ln 4. Okay, and whenever we're dealing with ln e, this is very important. Whenever you see ln e, that is always equals to a 1. Okay, because I know so many people that will come over here and then they just get stuck and they don't know what to do. Whenever you see a ln e, it is automatically a 1, right? So when you see this ln e here, you just replace it with a 1. Okay, so this is basically saying x plus 9 times 1, and this x plus 9 times 1 equals ln 4. And x plus 9, anything times a 1 is basically the same thing or number. This is x plus 9 equals ln 4. So we're getting closer to solving x now, right? So see, first off, we took out the exponent and we took out the ln attached to the exponent also, and now we have to take out the ln attached to the 4 and use that to solve x. Okay, and in order for us to solve this part of the equation now, we have to first find out what ln 4 is, because we can't just come over here and subtract both sides by 9, right? We don't know what ln 4 is, right? So we have to find what ln 4 is, and we can use that by you can do that by using the calculator. Okay, so this is ln 4. This is 1.386. Okay, so ln 4 equals 1.386. So x plus 9 equals 1.386. Okay, So since ln 4 equals 1 point, we just replace ln 4 with 1.386. So this is, so now we can subtract 9 from both sides, okay? This is like any normal equation. Don't let it scare you in any way. This is how you're going to solve any normal equation. This is x plus 9 minus 9. Subtract 9 from both sides equals 1.386 minus 9. Okay, so this is x equals 1.386 minus 9. Okay, so let's check the calculator for what that is. 1.386 minus 7.614. Okay, so this x equals minus 7.614. All right. So now remember we're asked to round our answer to the nearest hundred. Okay, and first off, let me introduce you to what this means. So basically, a hundred basically means the number, the second digit behind the decimal point. Okay, so whenever you're asked to find any exponent of 10, right? So exponents of 10 are 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4, to whatever, right? These are exponents for 10, okay? So this is a 10, right? This is 10. This is 100 because it's 10 times 10. This is 1,000. This is 10,000, okay? But in this case, we're asked to find the nearest hundredth. Notice there's a TH behind the D, okay? There's a TH behind. So that means we're going to have to deal with the numbers that are after the decimal points, basically, right? So that means we're going to deal with negative exponents of 10. So instead of saying 10 to the power 1, 2, 3, 4, we say 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3, and so on and so forth. And we know when we have an exponent with a negative at the top, this is the same thing as the derivative, as the as the basically we're just gonna divide the 10 by 1. Okay, this is 1 divided by 10 equals 0 0.1. 1 divided by 100 equals 0 0.01. 1 divided by 1,000 equals 0 0.001. Okay, so basically this is what a tenth means. So hundredth, this is a thousandth. Sorry, I'm kind of clean that up. Okay. This is a thousandth. Okay, so this is basically all because we're gonna have the points. We're gonna have the points after the numbers. Okay, so let's look at this. The tenth in this case is the first number after the decimal point, right? But the hundredth is the second digit after the decimal point. So if you see this decimal point, this is the decimal point here. The second number after this decimal point is here, right? Which is in this space. So in this case, we're asked to find the nearest hundred. So we're going to look at this number because it's the second number after the decimal point. Okay, so this is, and so based on that, we're going to ask yourself, what is the number after this second digit here? The number after the second digit is 4, right? In this question. And so we're going to ask ourselves, because we're going to round the answer right now. Okay, so in order for us to round the answer, we're going to ask ourselves, is that number after the second digit, which in this case 1, is that number, which is 4 here, is that number greater than or less than 5? Okay, so if that number is greater than 5, we're going to add 1 into, with this one over here, and we're going to cancel whatever that's behind the 100 value. We're going to remove it and set everything set to 0. Okay, but if it's not, then we just have to leave 1 as it is, but we're still going to have to change everything behind it to 0. Okay, so we're going to ask ourselves, is 4 greater than or equals to 5, or is it less than 5? 4 is less than 5. Okay, and since it's less than 5, we don't add anything. We don't add 1 to this one over here. But all we do is we just remove the 4 over here and set it equals to 0. So that's what we're going to do. So we're going to say x equals minus 7.6. See this 1 over here, we'll just leave it as it is. And then whatever that's behind the 1 turns into a 0 automatically. This is 0, 0, 0, whatever that's behind it. Okay, so if whenever I say 0, this is basically just saying minus 7.61. So we don't mind the zeros anymore because they're cancelled out. Okay, so this, let's put in the answer, minus 7.61. Yeah, okay, that's a good one. Okay, so let's go for another practice. Let's test our knowledge. Sorry, my wrist is acting up. My bad. Okay, so we're gonna use the same approach we used in this question, right? We're gonna use what we did here. We're gonna do the same thing here. Feel free to pause the video if you want. If you want to test yourself, just feel free, right? But I'm still gonna work on this. Okay, so it's basically the same type of question we're given, right? Okay, so the first step that I said in the first example is I want to set the logarithm of both sides, right? So I'm going to put a ln here and a ln here like I did over here. Okay, so I'll multiply ln times e to the power of 9y equals ln 12. Okay, so this is ln e to the power of 9y equals ln 12. Okay, so this is an exponential function, right? This is an exponent. This is an exponent basically, and it's attached to a logarithm function, right? So we're going to use the same concept we used here, but whenever we have an exponent attached to a logarithm function, basically just taking the power and multiply with whatever the logarithm is. Okay, so we'll take this 9y, we'll put it here at the front and multiply it by ln e. So this is 9y times ln e equals ln 12. Okay, so ln e is, remember, ln e is a 1. Okay, so that's taken care of. This is 9y times 1 equals ln 12. Okay, so the next step is finding ln 12, and we can do that by checking the calculator. So let's check that. This is ln 12, 2.4849. Okay, so ln 12 is 2.4849. So this is 9y equals 2.4849. Okay, and you're gonna work with this like you work with any other equation, any normal equation. If you're given something like this, all you have to do is divide both sides by 9. Okay, so you divide here by 9, divide here by 9 also. So when you divide here by 9 and here by 9, this turns to y equals, put that in real quick, 2.4849 divided by 9. This is 0.2761. Okay, so this is equals 0.2761. All right, so now we got that covered. We're gonna have to, because we can't just put in the answer like this, because remember, we have to round the answer to the nearest hundredth. Okay, and as I said before, the hundredth is the second digit after the decimal point. So the second digit after the decimal point in this case is 7. Okay, so we're gonna ask yourself, what is the number after 7 in this case? And the number after 7 in this answer is 6, which is this one. I'm going to ask yourself, is that number, which is 6, is that 6 greater than 5, greater than or equals to 5, or less than 5, right? So if it's greater than 5, which in this case it is, we're going to have to add 1 to 7 and then cancel out everything behind 7. So everything behind 7 will be set to 0. Okay, so 6 is greater than 5, right? And so that's what we're going to do. We're going to add 7 plus 1, and then everything behind 6 turns into a 0. So this is a y equals 0.28 now. Okay, because this is 7 plus 1. But everything behind the 7 turns into a 0. So that's automatically a 0, 0. And since we don't actually need 0, 0, we can just leave it like this as it is. So this is, let's check that out. 2, 8. Check. Yeah, okay. Okay, so thank you very much for watching the video, and I really hope it helped you out. Have a nice day.